Right guys, thank you very much for tuning in. I'd like to talk about the movement of free charged particles, freely charged particles applied in an applied B field. Movement of free charged particles in an applied B field. So just to let you know that the convention you have to follow is the understanding, spatial visualization of the Z positive, Z negative, X positive, X negative, and Y positive and Y negative axes. Another thing you need to realize is that the direction of the wire will be opposite to the velocity of the electrons. So the conventional currents will always be 180 degrees opposite to the velocity of electrons. So you have to realize that this is quite simple. Now there are two types or two directions of the B field. Either the B field is like this, or it's like this. Now this is 2D representation, either this or this. Now another kind is, imagine a pen and it's going into the page and it's deemed a cross, and it's going down into the page. And the other one configuration is coming out of the page, coming out. Right, let's examine the first one. What you have to do is you have to use the Fleming's left-hand rule. You have to use this every single time. You only use it for motors and charged particles. You do not use it for generators. For generators, it's the right-hand rule for generators. Alright guys, so now if the B field is in this direction, B field yes. Now for the first one, if we introduce an electron here and B field is going this way, so it's very difficult, and the electron, the wire is placed like this. If the wire is going in this manner, in this direction, then the flow of electrons would also be in this way, in this direction. And so it would be, hang on, so the field is this way. Oh, it's very difficult. Hang on, let's not do the 2D one. Oh, right, so hang on, let me try again. So field is this way. The current is also, no, that's not going to work out. For 2D, it's not for 2D, it's for 3D. Now, when you introduce a wire going this way, the actual direction of the current is this way, and the B field is this way, the current is this way, and so, sorry, the velocity of electrons is this way, the direction of the current is this way, because we placed a wire facing this direction. So it would be hang on, so field is into the page, and then it would be, yeah, downwards, it would spiral downwards. So electron, when into the page, it would go down, velocity of electrons, but the wire would experience an upward force, the electrons would experience a downward force. We're not talking about the wire right now. And the proton, So the proton would be, if the wire was placed in this manner, in this direction, it would be upwards. Proton would experience it upwards into the page. Now that's now coming to coming out of the page. It would be like it's coming out like this, and the field is like this. The direction of the wire is this way, so the direction of the current would be this way. Sorry, the flow of the electrons would be this way, so the electrons would feel an upward force. So the notation would be, this is how you write it in an exam, because it's succinct and powerful, and it shows you know your concepts. And electrons in an out of the page B field would experience an upward force. The wire would move down, but the electrons would feel an upward force. Now that's, hang on, you need to realize right now we're talking about freely moving charged particles in an applied B field. We're not talking about the wire. So the only reason I mentioned wire was to make you visualize how, you know, the difference between conventional currents and the flow of electrons. So just forget about the wire for now. Just you know, let's just say, so in this case, the field was inside the direction of the electron. If the direction of the electrons is this way, then the force would be upwards, depending on the direction of the electrons. So if it's going this way, it would go up. If it's going this way, it would go down. So hang on, let me show you how. Oh, yeah. So if it's going left, and just happened. Yeah, like that. And then for proton it would be opposite as well. So for proton it would be yes. Now this is how you write it and make your life easier. And so if it's going to travel, if the electron is going to travel this way, the thrust will be upwards, which is going from left to right. So going right, it would be pushed upwards. Going left out into the field would be pushed downwards, like this. And proton would be completely opposite, so you don't need to calculate proton. Once you've done electron, the rest is simple. And for sorry, it's a bit crooked. Yeah, so for into the page, so for out of the page, so for out of the page, an electron would be, if it's going to the left, it would be pushed upwards. And if it's going to right, it'll be pushed downwards. Let me show you how. So if it's going to the right, it's going to the right, it'll be pushed downwards. Sorry, hang on. Field, current and thrust. It's going to the right, it'll be pushed downwards. If it's going to the left, it'll be pushed upwards. And it'll be opposite, and that'll be opposite for a proton, completely opposite for a proton. A proton going left will be pushed downwards, and a proton going right will be pushed upwards. So I hope it's all about using the right method in these questions. Now, when the question comes about an electron in a B field, forget about the wire. Don't think about the wire. And when it's a wire, then it's a wire. Then don't think about the freely moving electron. Think about the wire and the conventional current. That is the key. I hope you learned something today, albeit it was a bit hastened, but it's for KS5, which is why I didn't bother to explain all the other physics terms, because I expect you to know the rest of the physics terms. So that's that, and I hope you learned something today. And please take a screenshot if possible. I'll help you out with the screenshot. And 5, 4, 3, 2, 1, and I hope you took it, and have a lovely day. If you've got any questions, please post them down below in the comment section. Try my best to answer every single question. Thank you. Take care. Bye now.